We're going to continue on in our lessons about sequences. This is part 2. We have one objective today, and that is to find the terms of a recursive sequence. But before we get into doing that, let's talk about what a recursive sequence is. A recursive sequence provides the first term or terms and a formula for the nth term to find the remaining terms. So we're still given a general formula with the recursive sequence, but we're also given the first term or couple terms because we'll need those in order to find subsequent terms. So let's see what this looks like. So example 1, find the first 4 terms of the sequence defined by, so we have a sub 1 is equal to 5, and then we have a sub n plus 1 is equal to 2 times a sub n minus 3. So we're already given a sub 1. So the next term that we need to find is a2. Now notice to get a2, we're actually going to use n is equal to 1. Okay, so we're not going to use 2. Look what would happen if we did that. So if we used a sub 2, if we used n equals 2, we would get a sub 2 plus 1 equals 2 times a sub 2 minus 3, which is a sub 3 is equal to 2a2 minus 3. We don't have a2 yet, and this gives us a3, not a2. Okay, so I'm going to erase this. So with this, you have to be careful at what n value you start with. Okay, so we are going to start with n is equal to 1 to get a sub 2. So for a2, start with n equals 1. Okay, so we have a sub 1 plus 1 is equal to 2 times a sub 1 minus 3, which means a sub 2, oops, I'm going to run out of room if I'm not careful, which means that a sub 2 is equal to 2 times a sub 1 minus 3. Now notice we know what a sub 1 is, so we have to use that term that was given to us in order to find the next terms. Okay, so we have a sub 2 is equal to 2. A sub 1 is given to us as 5 minus 3, which gives us 7. Okay, so a sub 2 is equal to 7. Next, we need to find a sub 3, so we'll use n is equal to 2. So we have a sub 2 plus 1 is equal to 2 times a sub 2 minus 3, which gives us a sub 3 is equal to 2 times a sub 2 minus 3, and we just found a sub 2. So with this type of a sequence, you can't really jump ahead. Like previously, we were given the general formula and we were able to find a sub 10, for instance. But in this one, we have to find the terms in order because they rely on previous terms. Okay. So 2 times a sub 2, which is 7 minus 3. So that's 14 minus 3, which gives us 11. Okay, so let me erase this. So a sub 3 is equal to 11. Next, for a sub 4, we use n is equal to 3. So we have a sub 3 plus 1 is equal to 2 times a sub 3 minus 3, which means a sub 4 is equal to 2 times a sub 3 minus 3, which is 2 times 11 minus 3, which is equal to 19. So a sub 4 is equal to 19. Oops, not 119, just 19. So we have found the first 4 terms. A sub 1 was already given to us. We found a sub 2, a sub 3, and a sub 4. Next, find the first 4 terms of the sequence defined by, we have a sub 1 is equal to 4, a sub 2 is equal to 3, and the formula for the general term is a sub n plus 1 is equal to a sub n plus a sub n minus 1. So lots of a sub n's. So we're given a1 and we're given a2. Next, we need to find a3. In order to do that, we're going to use n is equal to 2 because 2 plus 1 is going to give us a sub 3. Okay. So we have n is equal to 2. So we have a sub 2 plus 1 is equal to a sub 2 plus a sub 2 minus 1. So this gives us a sub 3 is equal to a sub 2 plus a sub 1. Now we were given a2 and a1, so we just substitute those values in. So a sub 3 is equal to a sub 2 is 3, a sub 1 is 4, which means a3 is equal to 7. Okay, so in this case, we were given the first couple of terms. We were given more than one, but we still needed to use both of them. Okay, so next we need to find a sub 4, so we'll use n is equal to 3. So we have a sub 3 plus 1. Okay, now you don't necessarily have to write out all that I'm writing out here. I'm just writing it out so you can see where these numbers are coming from or how we're getting a sub 4 or a sub 3. But if you can just, if you don't have to write 3 plus 1, you could just jump into a sub 4. That's totally fine. So where was I? a sub 3 plus a sub 3 minus 1. So we have a4 is equal to a3 plus a2. A3 is 7, A2 is 3, so this means A4 is equal to 10. So we have the first 4 terms. Okay. Next, our third example, find the first 4 terms of the sequence defined by. So we have a sub 1 is equal to 7. And then our formula for the general term is a sub n plus 1 is equal to 1 plus 1 over a sub n. So we have 1 over, which means fractions are going to come into play. So we need to find the second term. So that means that n is going to be equal to 1. So this gives us a sub 2 is equal to 1 plus 1 over a sub 1. A sub 1 is 7, so this is 1 plus 1 over 7. Don't leave it like this. We have to get common denominators in order to add these together. So our common denominator is 7. So if I multiply by 7 on the bottom, I multiply by 7 on top. So I have 7 over 7 plus 1 over 7, which is 8 over 7. So a sub 2 is 8 over 7. Okay. Next, we have n is equal to 2. So we have a sub 3 is equal to 1 plus 1 over a sub 2, which is 1 plus 1 over 8 over 7. Okay, so there's a couple ways to deal with this 1 over 8 over 7. You can write it out as, and I'm going to do this in a different color, so you can write it out as 1 divided by 8 divided by 7. When we multiply fractions, we keep the first one, we change the sign to multiplication, and we switch the numerator and denominator of the second. So this can become 1 times 7 over 8. So it's just 7 over 8. Okay. The other thing you could do is 8 over 7 is in the denominator. You can multiply by the reciprocal on the numerator and denominator. So 1 times 7 over 8 is 7 over 8. And over here, the bottom just becomes 1. Okay, so whatever way you deal with that is up to you. But this is going to become 1 plus 7 over 8. And now we need to get common denominators again. So I need to multiply by 8 on the first one. So this becomes 8 over 8 plus 7 over 8, which is 15 over 8. Okay, and so we have one more to find. So I'm going to click over to the next slide. We need to do n is equal to 3. So we have a sub 4 is equal to 1 plus 1 over a sub 3. 1 plus 1 over 15 over 8. Same thing, we have to find a way to deal with the complex fraction, which is when we have a fraction inside of another one. If you do 8 over 15, you're allowed to multiply the same thing to the numerator and denominator of a fraction. So the bottom becomes 1. So this becomes 1 plus 8 over 15. And if we put the 1 over 1, we need to multiply by 15 on the top and bottom to get common denominators. So this is 15 over 15 plus 8 over 15, which gives us 23 over 15. Let me make that 5 a little bit better. Okay. And so that is, we found the first 4 terms. We just need to go up to a sub 4. Thank you for watching. If you have any questions, feel free to reach out to me.